A set is a collection of objects. Let's say you have a collection of baseball cards, and a friend of yours has a collection of baseball cards. You want to figure out, or you want to talk about, the cards that both of you guys have in common. We have a set operation for this purpose. It is called intersection. The symbol we use to represent intersection is a downward U, and sometimes you will also see a downward V. Either way, both of them mean the same thing. Let's say you have two sets, any two sets, set A and set B. And these sets could have any elements that you want. Their intersection, which is written as A intersect B, is a set consisting of all those elements that are in A and that are in B. This is read. The intersection of A and B is a set consisting of all X such that X is an element of A and X is an element of B, meaning that the intersection has those elements that are common to both sets. Let's look at this using Venn diagrams. This black circle here represents set A. This red circle represents set B. So the black circle has in it all the elements of A, whatever they may be, and the red circle has in it all the elements of B. Then the intersection of A and B is the area of overlap of these two circles. Because the intersection has those elements that are in both sets. Let's see a few examples of this. Let's say A is a set whose elements are the numbers 2, 4, 6, and 8. And B is a set whose elements are the numbers 6, 12, 18. We want to find A intersect B. Well, we said the intersection has only those elements that are in both sets. That is, the element has to be in A and it has to be in B. If we draw a Venn diagram for these, we would have, here's our set A, here's our set B. So the elements in A are 2, 4, 8, and 6 is shared because 6 is common in both of these sets. So 6 goes in the middle. And the elements that are only in B are 12 and 18. So our intersection in the middle here has only one element in it this time, and it's a 6. So we're gonna write it here that the intersection of A and B is a set consisting of only the number 6 because that's the only number common, or the only element that is in both sets. Let's have another example. We form a set P, and this is a set whose elements are the letters E, M, P, T, Y. And we have a set Q whose elements are the letters A, B, C, D, E, and M. Then the intersection of P and Q, which is written like this, will have only those elements that are in both P and Q. Well, let's see. We have E here and E here, and M here. So E and M are in both sets P and Q, and then they will be in the intersection of these two sets. So we write E and M in the intersection. Let's say we have another set called R, and the elements of this set are the numbers 1, 2, 3, 5, and 7. We want to find the intersection of P and R. Again, this is going to have elements that are in both P and R. But we notice that P has letters and R has numbers, and they don't have anything in common. So our set P intersect R is going to be empty. Another way to write it is a 0 with a slash sign. This is saying empty set. Okay, one more example. We're going to form two new sets. Let's call the first set S, and this set has the numbers 0, 1, and 2 as its elements. And we have another set called T. This set is an empty set, and we want to find the intersection of S and T. Remember, the intersection has only those elements that are in common among the two sets we are taking the intersection of. Well, if one of the sets is empty, then what elements do they have in common? Nothing. So their intersection is going to be empty. Now you should make up a few sets of your own and take their intersections.